Okay, so welcome. My name is Vincent Keizer. I'm a developer at Capgemini. I'm going to talk to you about improving code quality. I want to show you some basic tips how you can easily improve your quality of your code. I want to show you how you can implement it in your current process and workflow. And I want to end up with some live coding based on these practical tips. You can download the presentation and the code samples from my GitHub. The link is on this slide below, and it will be also available in this presentation. Um, so first off, improving code quality. Well, the first question, of course, is what is code quality? I think it depends on who you ask because there are so many different opinions. Some people talk about no duplication or all generic code. Some people talk about design patterns. But tonight I want to talk about something else because I see this in a lot of projects I've worked on. Um, and I can share some basic practical tips to improve this code. You can start with it right away. Well, there are many more other ways to improve your code quality, but we only have half an hour, so I'll stick to the basics. And the first thing I want to talk about is managing complexities. I think that's one of the most important aspects of code quality. And what I mean with that is give your code intention. Let your code tell what you are trying to do. What is the problem that you're solving? What does this functionality do? And try to make everything as explicit as possible. Create abstractions around complexities so that your code becomes easy. And with easy, I mean easy to read, easy to understand, easy to maintain. Because let's face it, you're probably not the last developer to read this code. And this code will change in the future. Maybe the specs will change. Maybe in a few years' time, it needs to be ported to a different framework. So it's important that your code is easy to understand, because code that's easy to understand is easy to change, and then there are less chances on bugs. And so in the long term, it will be a higher productivity with less bugs and less costs for the customer. What I'm not going to talk about is design patterns. That doesn't mean that I don't think that they're important. I think they're very important. I think that you should learn them. And they're important for many reasons. For example, they're great building blocks that's proven over time, and it gives you a universal vocabulary with other developers. So when you're talking about a factory, the other developer knows what a factory does, or at least should do, and that gives you a big advantage. Um, so my first tip is naming, and it's one of the most important things to do. Maybe it sounds like a no-brainer, but it's absolutely not. It's one of the most difficult things to do. And with naming, I mean the naming of your classes, of your functions, of your namespaces, of your variables, and even your unit tests. Give them an intention revealing name. So give them a descriptive name and describe exactly what it does, and try to make it as explicit as possible. So tell what this class, method, variable does, and yeah, keep it functional and feature-like. So not a technical name, but really try to describe what this functionality does, and try to do that in the domain language. So don't use any technical names. Don't come up with your own names. Go to a domain expert and ask him or her how they call that entity, and use that name and use it consistently throughout your application, or at least the domain you're working in. And these intention revealing names apply to functions or methods as well, but there are some other rules I'd like to apply to functions. One of them is keep them as small as possible. I usually try a maximum number of lines of 4 or 5 lines of code. And when I first heard about that way of working, I thought it was impossible. All my functions were way longer than 4 or 5 lines. But when you try to keep your function like that it does one thing and has one responsibility, it is possible. And when you chop your class up into several functions, you will see that a flow will become in your class, and you can see what this class does based on all the functions it uses. And also keep your function side effects free. What I mean by that is when you call a method several times, it will always give the same result. So when a function is not side effects free, it probably means that your class is stateful. That's something you should try to avoid if possible, of course. And keep your arguments to a minimum. The more arguments, the more complex your function gets. And of course, keep it testable. And the same rules apply to classes. Keep them small, give them an intention revealing name, and make sure that they only do one thing. And when your class is doing one thing, you'll see that it gets more testable. So when a class and you're trying to test and you have to make many marks or stubs, it probably means that your class has too many responsibilities, or at least too much dependencies. So try to keep that to a minimum. And group your group your classes together based on a namespace of features and functionalities. Try to avoid bad namespaces like enums and interfaces, helpers, extension methods, mappers. They're all based on technical terms or types. And that's not what you're working on. You're working on features or functionalities. So try to add that to your namespace, and try to avoid putting classes in the root. It maybe will look fine at first, but it will become a mess in the future. In this example, I show you two types of namespaces. The right one is based on the features and functionalities. So you can clearly see this is probably about file processing, and there's a file reader, some writing, some validating. When I look to the left side, I see all technical terms. I have no idea what this domain is about. It doesn't give me any intention of the code at all. When I need to change the validation, on the right side, I can see it probably in the validating namespace. And on the left side, it's probably in more than one namespace. So I need to go search for the classes. And in the right side, it's more clear where the classes are. So try to base it on features and functionalities. This is some examples from the demo I'll show you later on. So keep it in mind. And of course, your application will have external dependencies. And I think that's okay. You shouldn't, and you can't write all the code yourself. There are great libraries out there that you should definitely use. So don't be afraid to use external dependencies, but create an abstraction around it. Put them behind an interface. This will make it more manageable with updates. For instance, when a dependency gets a major update with some breaking changes, you only have to adjust that isolated piece of code and make sure it compiles again, instead of that you have to redo your entire application because you use it all over the place. And another thing is, because it's behind an interface, it's easier to test your own code. You can create a mock for that interface, because you're not interested in testing the external dependency. You're only interested in testing your own code. So it gives you several advantages. And if you look at this example, this is a wrapper I use most of the times, and it's a wrapper around the Newton Soft JSON. Probably everybody knows this. It's a simple interface and the implementation, just one line of code. This just takes like 1 minute to write, but it gives me a lot in return. So it's a good investment. I would surely recommend doing this. Another thing I see most of the times, that people are afraid to throw exceptions. And I think when your application gets into an invalid state, don't be afraid to throw exceptions. Don't continue with null objects or even do nothing in your class. And the same applies to invalid arguments. When somebody provides an invalid argument, just throw an exception. Don't continue, because it will create exceptions at a later point in your application. And it's way more unclear than just throw an exception. Yet again, an example of the demo application I'm going to show you later on. On the upper hand of the screen, you'll see a method that doesn't throw exceptions, just has an if statement and checks if base path and type are null or white space. And it does nothing. So when this application, when it receives some invalid arguments, nothing will be logged. There's no information. So when this happens on production, you have no clue where to go and look for the problem. At the bottom side, you'll see the parse files. It has like the same if statements for base, path, and type, but now it throws an exception with a clear message. You still need to handle this at the right level, but at least you know now what's going on in your application. You can even write this more easy, but I'll show you to that in the demo. Another thing about this method is that you see that there are 5 strings as arguments. I'm not a big fan of that. I would suggest to use models or some richer models for that, because it's easy to make a mistake with these arguments. When you mix them up, the compiler will accept it because they're all strings. It doesn't give you any compile exceptions. And when you create models for it, it will give a compile exception because you've provided the wrong type. It's also a chance to give some extra intention to your code, so that it's not only based on the name but also on the type name. And you can even bundle some data together. For instance, when we're talking about names, you usually have a first name and a last name. That are 2 string arguments, but you can also bundle them to a full name. So you only have 1 argument with 2 properties in it. And you can even take that a bit further and give these models some responsibility. For instance, you could, the thing I also like to do is to make sure that a model validates the data and make sure that they're always in a valid state. But you can also choose to make them, for instance, immutable, or make some methods on the model to hide the data that should not be exposed. Yet again, the same method. The first one is with the 5 arguments. The last one, I've grouped some data together. The input path is a combination of the base path and the in folder. Validation type is the type of the first argument. I've given them a bit more intention revealing name, and the last one is out path, which is a combination of base path and out folder. So you can't mix it up. The arguments are a bit are from 5 to 3, so it's a bit more clear code, in my opinion. Okay, and at one point, your application will go into production. And do yourself a favor and make sure that there's some proper logging. And when I talk about that, I mean not only about exceptions, but create a trail. So create an entry for every decision your application take, and also create an entry for the arguments of your application, classes and methods, just to make sure you've got a good trail what your application does and what the decisions are that it took. And use several log levels so that you can see the exceptions and the information of your trail clearly. Okay, this is not really about code quality, but it's very important for your application. And sometimes you're stuck with a legacy application with a lot of code smells in it, and you really want to refactor. Well, no worries. There are plenty of good ways to do that. The first question, of course, is when are you doing that? Or when are you going to do that? In my opinion, the right answer is now. But you shouldn't do the entire application at once. I think you should apply the Boy Scout rule, and the Boy Scout rule is leave the campsite cleaner than you found it. So clean up all the files you touch, improve the code quality to the desired level. And because you're already changing that feature, it already has to be tested. So there's no extra test work. It's only testing that feature that you touch. And if you do that for all the features that you touch, you will see that the code quality of the application will increase over time. Another thing that's very important, in my opinion, is be transparent about it. Make sure that the product owner and the customer understands that you have to invest in code quality, that it will cost more time to clean up code and to refactor some code, but that it will save them time and money in the long run, because cleaner code makes sure that there are less bugs and it's easier to change. It's maybe a bit more future proof. So it gives them a lot of advantages, but that's in the long run. So they will save money in the long run. And don't overdo it. If it's not core business, it's okay if it's not like 100%, then maybe 60 or 70% is good enough. And before you start refactoring your code, make sure your code is unit tested. Because a unit test is a great way to validate your refactoring. If there aren't any unit tests, that's okay, because writing unit tests is a great way to understand the code. So make sure that you write the unit tests first, then you refactor your code to the desired code quality. Then you run your unit test again and make sure that they all pass, because then you know you didn't change any functionality. Another thing is that it's very important that the whole team understands that code quality is important. You can't do this by yourself. So try to get your whole team enthusiastic about writing good code. You could do that, for instance, by doing some pair programming, like working together on a feature that usually helps with pushing each other's level up. And talking about a solution will most of the time improve the quality of the solution. Another thing you could do is some pull request reviews, if you're not already doing that. And remember that comments are not a bad thing. It's a great way to help the developer and the code quality of the code base. And try to keep your comments positive. It's not about bashing colleagues, it's about improving the quality of your code base. And with team effort, I mean not only developers, but also testers and managers. They do have to understand that good code costs time, but will save time in the long run. So everybody needs to be on board about writing good code. Okay, now I want to show you some of these tips in practice with some live coding. I'm going to use a demo application based on a project I used to work on. There's a lot of code smells, and I want to apply these tips to make it more readable and maintainable. So I'm going to switch to Visual Studio now. Okay, what we see here was an application I started on. There was no unit tests, no documentation, and it's a console application. And when I'm looking at this interface, this was one of the only interfaces there were. It was about probably about a file parser with parse files and some get valid files and get invalid files. This feels already like a code smell, because probably these two are based on the result of this method. It has a lot of strings as arguments. And when we go and have a look at the implementation, we see that this method is very, very long. I need to scroll for a long time to see the end of the method. There are a lot of if statements. I see a lot of external dependencies. Maybe you think that this isn't a external dependency, but it actually is, if you ask me. It's from the .NET framework, but it doesn't help me to unit test this code, so I still want to put it behind an interface. It's code I haven't written, so I consider this a external dependency. Well, you see there are a lot of system calls, so a lot of external dependencies. To save some time, because we only have half an hour, I have already done that. I'm going to show you how it looks. It looks a bit like what I showed in one of my slides. For instance, let's go to the directory reader. It's a simple interface with just one method. And the one method is a wrapper around the same line that you already saw. So when we look at the result of this class, dependency injection now injects 4 interfaces. The code is exactly the same, but now we have like these wrappers around the system calls. This makes it possible to write some unit tests for this application. I'm going to show you how they look like. But you already see it. There are a lot of mocking and stubbing and setups. So it's a very complex unit test. And that's not what I prefer. I think your unit test should be as simple and should the same code quality rules apply to your unit tests as your normal code. And I prefer unit tests with the following name. The first part of the name is the method I'm testing. The second one is the situation I'm testing. And the third one is the result I expect. So that's very easy to see what this test does and what I'm testing. But we need to work on this because this is too complex. But first, let's try to understand the application a bit. And I want to start off with chopping it up in some small functions. So let's start here. This is a part I can move to a function. I'm pressing Ctrl RM. This is a shortcut for extracting methods. This is ReSharper. It's an extension to Visual Studio. It's very handy when it comes to refactoring. I can now enter a new name. This looks like a method that writes valid files to disk. Write valid files to disk. Okay, it created a method. Now let's continue. This part of the application gives me the valid files. But again, Control RM helps me with the name a bit. Get valid files. I'm going to remove the empty line. This part gives me the file contents of a file. The file contents. And I even move the if statements to a separate method. For this, it's questionable, but when the if gets too complex, it's very good to move it to another method because you can give a clear name to what this if statements should do. Has files. And let's move this. This gets the file from the in folder. Get files from in folder. Move this to another method. Extract method. Are arguments filled? Okay, so now we the only thing we've done is chopped it up into several methods. Now it's readable what this method does. It first checks the arguments, then gets the files from the in folder. If there are any files, it gets the file contents, and then it gets the valid files. Then it writes the valid files to disk. Okay, that makes it a bit more clear. So now we understand that it's not about parsing files, but it's about processing files. So we can rename this method. I'm pressing Ctrl RR. It's a shortcut for rename. Process files. I'm also renaming the interface. Yet again, Ctrl RR. File processor. It also updates the class name. The only thing ReSharper doesn't do is rename my files, so I have to do it manually. It used to do so, but I don't know why it doesn't anymore. Processor. I'm going to create a namespace because I don't want to have them in the root. File processing. Select my files. Ctrl RO is for moving files. It automatically adjusts the namespace, so that saves me some time. Okay, the next thing is these two methods. Let's try to make this side effects free. So I'm going to remove this two, and the easiest way to do it is just let this return a model. Let's call it process summary. Oh, shouldn't have done that. It added a reference to another project. Create a new class. It's a summary. Let's make it public. Okay, we could do it like this, in a good old DTO way. Total number of files number of valid files, even a int number of invalid files. This could work. This is just a basic DTO. But we could give it a bit more responsibility. First of all, let's try to make it immutable. Total number of files, number of valid files, number of invalid files. Number of work a bit better. Number of invalid files, number of. Okay, now we could remove the setters. Now it's immutable. It's a bit better. Now only the file processor can create a process summary and can't be updated elsewhere. We could even go a bit further and make sure that the process summary is always valid. We can create some guard for it. I already showed you in a demo how it should be done with an if statement, but I created some simple helpers for it, and you can do that as well. I created some if greater than or equal to 0, if greater than 0 is not null, or white space. These are things I use almost all the time. You can also add extra if you want to. And when you use that in your application, it doesn't cost any time at all. I need to go to the process summary. Assert. We want the total number of files to be greater than or equal to 0. Name of is required for the exception message. Same thing applies for the number of invalid files. But we could write some extra guards to make sure that total number of files is always greater than or equal to the number of valid files and the number of invalid files together. But you get the point, so I'm gonna skip that now. But you can also write some unit tests for the process summary. Because the process summary has some logic in it, we can create unit tests for it. I'm gonna show you how that looks. I already done that. And these tests are very, very clean, very small. So here I'm testing the constructor. I'm adding a summary with some numbers, and I check all the inputs. I also check all the guards to make sure that they throw exceptions when I provide invalid arguments. And all these unit tests are very small. This is the way I like the unit tests. They're very easy, no mocking or stubbing, so very, very clean code. The next thing we could do is, because we have created these small methods with only one responsibility, it's quite easy to go to the next step, and that's create classes with one responsibility. And that means we can easily move this code to a separate class so we can test it easier. So for instance, let's go to the get valid files. This is the part that validates the file contents, and we can move that to another file. I'm gonna show you how that looks because I've already done that just to save some time. I'm gonna go to the validating, and here you can see the namespaces. I know that the files for validating are in the validating namespace, so it's easier to locate them instead of namespaces based on types or technical terms. So this class now does the validation. I moved it to a separate class with some interfaces, and this is the only code that was necessary for the validation. It gets the validation type and a model for the file contents. I created a model for it because I don't like to use strings all the time. And if you look at the unit test for the validation, it's the same as the process summary. They're very small. I create a validator, then I first create the tests for my guards, and then I create the validation of the unit test for the validation itself. There's no stubbing, there's no mocking. It's pure testing of the logic. It's very clean, very easy to change when this class has to change. So this saves a lot of time, and it makes your code very clean, in my opinion. And when we look at the result of the file processor, you'll see the classes that are injected are still 4 classes, so that hasn't changed. And when we go to the methods, we see that the methods are now like 1 line, 2 lines of code. We just call the other interface and get the result and return it. So it's very clean. There's no logic in this class at all. It's all moved to separate classes, which are unit tested by itself. Okay, well, that's about it. I'm wondering if there are any questions. I don't hear.
There are a couple of questions.
Good.
The first one is from Lars van der Vliet. He asks us if the business or the business or the customer uses Dutch business terms. Would you translate those terms into English or use the Dutch terms in your code?
No, I would stick to the domain language and use the Dutch terms, and use words like get and set in English because we all know that, and the domain term I'll keep in the language they're used to, so Dutch or maybe French or.
Okay. Yeah. Okay. Good. And I have one question myself. You were using Visual Studio for this. Can you also use Visual Studio Code? Is that convenient as well?
Yeah, you can even it works the same. You maybe don't have ReSharper, but still same rules apply. And it's not only bound to C#, it's also bound to Java or JavaScript, or you can. It's just concepts, and you can use it in all kind of languages. So it doesn't. It has nothing to do with an EDA. It's just concepts of code, and you can use it in every language you want.
Okay. Yeah. Great. Do you see this used at customers as well often, or?
Not as much as I'd like to. It gives us an opportunity to bring it to the customer and show them why we are, or at least I think we are good developers, and that they can really benefit from this kind of code.
Yeah. So we should advocate that more into with our projects when we are at clients.
Absolutely. Yes.
Yeah. Okay. So thanks for this great presentation. Really good session. Really awesome. I learned a lot from it. So thanks a lot.
Yeah. Thank you for having me.